Hello, everyone again. And I think we should start today's meeting. So today is our final sixth meeting of the first session of the Bioinformatics Club seminars. And as usual, I remind you that this series of meetings is dedicated to discussion of certain best practices for data analysis, and the first session in particular is about the reproducible research techniques. And today we have the last topic, which has been left behind, I think, in the middle. So we left it out a little bit to switch to more interesting ones, probably. And today we conclude the session with the discussion of containerization, virtualization, and the usage of these technologies in bioinformatics. Again, as usual, I have sent the link to the form in the chat, and I will repeat it once again. So basically, there is the link to a usual questionnaire, a short questionnaire, which contains several questions related to the topic, which we'll be using during this meeting. And today, as I've announced previously, we'll have a little bit shifted format of the meeting. So probably I will speak a little bit more this time, given that the topic seems to be a little bit less covered, and fewer people, at least given our previous questionnaires, few people have really good experience with the subject of today's talk. But as usual, I'll be directing the questions to the experts, and as usual, we are welcoming all of the comments from both the audience and the experts. And as last times, we have today with us, similarly, Gennady Zakharov from Ipan Systems. Gena, hello.
Yeah, hello. I'm unfortunately, as usual, from mobile phone, so don't have good connection and microphone, but yes, I'm here. Fortunately.
Okay, I think we'll we'll manage that. Yeah, thank you. Roman Chernachik from JetBrains Research also with us today. Hi, Roma.
Yeah, hi everyone.
And Alona Kizenko from Austria. Alona, hi.
Hello.
Yeah. So that's the usual expert panel for us today. And as I've already mentioned, the topic of today's meeting is containerization and virtualization. I should first give also credits to Gennady, because the presentation which I'm going to show today is partly inspired by his slides, which at first we thought that he would be able to present himself, but due to technical reasons, we switched the presenter. But still, again, many thanks to Gena for helping to prepare the slides for today. And the subject.
Yeah, anytime. In fact, it was not right for today. It was for my seminar, but it doesn't ready yet. So I'm glad that you have.
Yeah, and thank you for
the slides. So it's beneficial for you.
Yeah. So as I've said, the topic of today's meeting, I think, is very well illustrated by this meme, which is shown on the slide. For this particular slide, I should give credits to Alexander Predeus, who's also sometimes been a member of our expert panel. Unfortunately, has not been able to join us today live, but he advised me to include this one. I think it's quite a nice one. So basically, that sums up, I think, quite well the idea of all of the virtualization and containerization when you have multiple embedded systems, like a virtual machine installed on one system, which can run containers within it, which basically creates this Matryoshka doll in a way. Yeah. But for clarity and for all the people to understand what they're talking about, I think it's important at first to say a few words about virtual machines, about containers. So what's the motivation for using both of these, and what's the benefit? And again, I remind you that the title of this session of the seminars is computational methods for reproducible research. So the main topic of which we are talking about is reproducibility and things which may help get more reproducible results. And we already discussed a lot of things related to this. We've discussed pipelining languages, we've discussed virtual environments, we've discussed notebooks for downstream analysis and cloud computing. And essentially, containerization and virtualization, like hard virtualization, also aid in making the results more reproducible. Because the main idea of both virtual machines and containers is to create an isolated workspace for the user, which can then be used to run a particular software in this enclosed, isolated environment. And I think that the users and the listeners who have attended our previous seminars, especially the one which was dedicated to the discussion of Conda and related things to manage environments, would ask. So basically, at that time, we also talked about isolation of software in particular environments. So essentially, what's the difference? And the answer will be that unlike virtual environments, when we are talking about hardware-based or software-based virtualization or containerization, this is a set of tools which allow us to create a much more isolated space, completely or almost completely, if we're talking about containerization. So basically, where everything is almost independent of the parent operating system. Of course, this is surely still dependent on the infrastructure you use. And it's based on the infrastructure, but generally this is in case of real virtual machines. When we're talking about the strict sense virtual machines, they have basically their own operating systems and their own hardware. So this is not, of course, a physical hardware, not a physical processor or physical RAM module, but rather a virtual CPU, virtual processor, virtual RAM, virtual memory. But still, this is in a special manner that's created as a separate virtual device. And in that sense, the virtual machine much more resembles a real physical machine, a physical computer, given that it has its own hardware, it has its own operating system, and it has applications put on top of that, on top of the operating system and the virtual hardware. And this is usually created through a certain software, naturally, which is called hypervisor. Sometimes it's also not simply a software virtualization, but also hardware-based, where there are certain elements of the hardware which assist in the creation of these virtual machines and the basically providing these virtual resources. And that's a very enclosed environment, which is, again, has its own operating system and its own virtual hardware. In contrast, containers, which is the second option, is a more soft option in terms of that it doesn't have its own operating system. And basically, the container engine, which runs these containerized applications, containerized software, it just basically translates instructions and things which are performed inside the container into instructions for the parent operating system and then hardware. So it doesn't include this own hardware set, and that of course makes it a little bit less isolated and more dependent on the parent operating system, but at the same time it makes it, which is beneficial, more resource efficient. So naturally, containers, unlike virtual machines, like sensu stricta hard virtual machines, they are much more resource efficient in terms of creation and management. So that's a true benefit of using containerized applications in contrast to deploying a virtual machine. So that's really it can be made at much lower cost in terms of both resources and the user time as well, because the creation of a virtual machine is usually more time consuming for the users as well, compared to starting a container. So that's basically the difference between the two. And again, the difference between the virtual environment, as I've said previously, the virtual environment is basically just a separate shell with links to libraries and software, which still uses like the same a lot of the same software and libraries, etc., which are included in the parent operating system, and naturally uses the same hardware. And in this sense, it is very slightly isolated from the parent system. It's still affected in I think in many ways by what happens on the parent system. Okay, both containers and virtual machines are in this sense much more isolated, and in this sense we provide better reproducibility. Yeah, I think there are comments.
Sorry.
Yeah, please.
Yeah,
sure.
I would just to jump into to summarize what you think. So the virtual environment, in fact, they don't provide any isolation because the application still access whole file system. And the virtual machines is a real 100% isolation, but it's very time consuming. And containers, I believe, why they become so popular, because they, in fact,
Okay, I think that's the connection issues which Ken mentioned. Or is that a connection issue on my side? So if anyone from the audience or experts could comment on whether we can hear me.
Yeah. But for the real good application, the containers are the perfect choice, and it's have the near the zero costs of the isolation, because they use the. In fact, the Docker and all this engine, it's a good combination of the mechanics that were implemented in the Linux kernel and in the Linux operating system. It's just a very good and easy way to use it. Everything what Docker Daemon, Docker engine is doing, you can do it by your own hands, but it will be just too time consuming.
Yeah, again, I'm sorry. Yeah, in the middle of what you have been talking about, I think there was a connection drop. So I think after the part of the story which I suppose you have been talking about the Linux kernel, etc. So what you were talking about in the middle, it dropped out. So if you could shortly repeat this part. Yeah, so we've heard that.
So just container, it's a. Yeah, it's a perfect balance point between the isolation and security and the resource overhead.
Okay, yeah.
And what is important is in container, you can analyze not only the one utility like in virtual environment. So for example, if you have some variant calling pipeline or something like this, you can isolate and pack into the container the whole pipeline with all applications, and be sure that everybody can run exactly the same software and versions which you are using.
Yeah, thank you. Well, basically, I should comment that, well, you could also install many things into a virtual environment and create a whole pipeline inside, but I think that's not a very good practice usually, especially if there are many tools. If there is a couple, then it's mostly okay, I think, but in case there is a lot of things, yeah, it might be too troubling using Conda or other virtual environment manager. But Regarding the perfect balance point, yeah, I do agree with this statement. Yeah, that if we are worried about the reproducibility issues, then like making a full scale virtual machine may be like more resource consuming, and like the resource overhead, which again I talked about. And in terms of virtual environments, this is not in fact an isolated thing. Yeah. Regarding the issue of of reproducibility, I think there was an example which I think on the seminar which was dedicated to the discussion of virtual environments, we had Alex Perdeus, who has commented on the fact that basically in his experience there are many troubling issues with Conda software. In terms of reproducibility, in terms of compatibility and match between the results obtained with Conda versions and basically the parent versions. So there is a lot of issues with that. So probably for production purposes, especially, and for pipelines which run basically are routinely used, containerization is probably a better option in these terms. Yeah, so again, I remind everyone that we have a questionnaire, and the link to the questionnaire is in the chat, and it was also sent out to you by email, so you can very well open the questionnaire through emails. And then we can look at the results. I think we can switch to that. So basically, as for now, we have 10 responses here. So if you haven't responded yet in this form, please feel free to open it using the link and submit your response. And as I think also as usual, we have half of the audience who are experienced bioinformaticians and half the audience who are basically entry-level bioinformaticians. And in terms of the usage of virtual machines and containerization, basically containerized applications, I think we have the majority of the audience. I bet that this is due to the experience, guys, but probably the majority of the audience will use both virtual machines and containerized apps. And also, I think quite a substantial fraction of the audience who have used only virtual machines but have not used containers, which is quite an interesting observation, I should say, given that, as we've mentioned, creation of a virtual machine is a little bit more complex in terms of managing it, and especially if you are about to run a single app, for example. And that's interesting that we have no one who have used only containers but have not used VMs. Yeah, and the third question in the forum, which we have here, is basically the use cases. Yes, it's also important to understand not only what people use or not use, but also what are the use cases. And as natural, we are talking about isolation of software. I think the most natural purpose of using containerized applications is to run a particular software tool in an isolated space. And I think that's the use case, which is of course more pertinent to containers, but it also can be very well applied to true virtual machines. But there are other purposes, and I think that we have many people who have used both virtual machines and containers for different reasons. I think that here we have an overwhelming domination, I think, of people who have used virtual machines and containers. I suppose that's mostly virtual machines, but maybe not, for various educational and testing purposes, which basically I think indicates that concordantly with the previous question, that the majority of the audience have at least sometimes used these technologies. And then in terms of the other use cases, we have, I think, quite a lot of people who have used virtual machines or containers. I also suppose that this is more about VMs, about running stuff under a different operating system. But naturally, we have all the other use cases with us here, including running of a particular tool, including using virtual machines for or containers for development of software tools, of web applications, and also to create isolated spaces for people on the larger infrastructure. I think that's also like quite a common case when you have a server infrastructure and you have, for example, students who want to work with this infrastructure and you want to manage the resources efficiently. Of course, you may have some sort of system which controls threads and which is used to make job queues and basically organize all of the computation, like Slurm, for example. I think it's quite popular nowadays. But even if you have these systems, I think quite often you may have people who are overusing the resources, taking too much space, taking too much memory, taking too much CPUs, and a single system, if you don't have like a cluster but a single unit, it may be troubling to manage the resource usage. And in this case, the creation of virtual machines on such servers may allow you to create a particular a small set of computational resources and disk space, storage, which are accessible by a particular user. And this is actually a use case which I have used virtual machines personally for. Interestingly, I have never used virtual machines for educational purposes. I think and I know many people have, but I haven't. But I have interacted very, I think, very intensively with KVM, for example, to create virtual machines for students and for seminars when you have a certain computational node and you have to separate it into many isolated spaces for each person, and be sure that this person will not use more resources that you would like him or her to use. And that's also quite a common use case for VMs, and I think we have quite several people who have used them for this purpose. Yeah. Having said that, I think I can also ask people in the experts about your experience of using virtual machines and containers. I think we may switch to containers later, or you may like separate and talk about your experience with real VMs and containers separately, so that we can understand what were the use cases for hard true like virtual machines and for containerized apps. So I think we can start with Alona. Alona, Gana? Okay, yeah. So yeah, Alona, could you please tell us about your experience with VMs and containers?
Yeah, honestly, I don't have a lot of experience with VMs or containers. I use it for like my first usage of virtual machine was when I was applying to Bioinformatics Institute, and then I had to install Linux on my like previous Windows machine, but it worked very good for educational purposes. But when I started to run something more heavy, it didn't work at all. So I just switched to Linux and never switched back. I'm very happy with Linux, and yeah, I don't use Windows anymore. And also now I kind of on the opposite team. So I have Linux, but I have Windows virtual machine that I connect to, because some of the tools like that I use, like graphical tools, they did not work on Linux. There is no Linux, like for example, Illustrator or Photoshop. And we have we also use Snapgene. Probably there is a version for Linux, but we have kind of a licensed one. And for this, I use the Windows virtual machine. And this is now I just switched the teams basically. Yeah, and for containers, to be honest, I think I tried to use Singularity once, and I think I even succeeded. It was a few years ago. I had to run the tool that searches for repeats in like different genomes, and I think I used No. I think I tried to annotate a genome with like breaker or maker. Yeah. And then I used the singularity on the cluster. And I think it was, I mean, you have to read about how to write the singularity scripts, but it was not super hard. Yeah, that's my experience.
Yeah, thank you. I think I can add that. Well, annotation tools, yeah, probably in many cases Docker is the only possible solution because they usually tend to have a lot of dependencies, especially this like maker pipelines, which contain a lot of software for genome annotation because you like search for genes, protein coding genes, you search for like RNA, tRNA, blah 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 blah, a lot of different stuff. And all of these tools usually have like their own like tool for a particular task, and a lot of dependencies make it very hard to install. I think the serial annotation pipeline, which is called Praca, was sometimes when I was learning bioinformatics, I should say that there was no Conda at that time yet, or at least it was not popular at all. And at that time, yeah, installing Praca on your own system was basically a very painful task. It was like really really something with like a boot camp for bioinformaticians. So yeah, probably for such tools, Docker is really the only solution if it has a lot of dependencies. But yeah, generally, it's interesting that yeah, you still use virtual machines for Windows graphical applications. It's nice. It's a nice use case. I think it should be mentioned. Yeah, thank you. So Gemma, what's your experience with both VMs and Docker?
Okay. So for virtual machines, yes, there were different operating systems even before the Bioinformatics Institute. So I tried different versions of Linux and then Windows, and just to play something new because I like to explore new systems and sometimes review the opportunities. That's what was with virtual machines. And with my experience with Docker and some orchestration engines based on Docker, it was mainly on the customer project when we were building some analysis infrastructure for clinical genomics. And so there were very important reproducible calculations. So we used Docker for this one, and the final solution what we recommend that the Docker not only the isolating, what I didn't say, haven't said before, that Docker is also a good way to distribute your packages, because you can create your own image, publish it into Docker registry, and anybody can use it. So it's a good way to have the reproducible pipelines. For example, you create some analysis for the scientific paper, you created a pipeline containing, I don't know, a dozen of utilities. And so you pack it into the one image, you publish it. The images are strictly versioned. And you can be sure that anybody who can want, for example, to reproduce the results of your study, so they can take exactly the same image and run exactly the same environment, byte-to-byte reproducible. And that's very important. And in my case, it was even more important for the clinical case, when you need to have very good reproducibility level, because this is a clinical diagnostics. This is the place when you sign some diagnosis for the patient. And so we finally got to this one, that we just set up all the libraries. In fact, the library conflicts, at least for such production utilities, are not the big case, and we can set up it's all in one system, but having this reproducible and versioning, it's very important. And when you run container, you can exactly trace that you run the specific version of the image, and you can trace all utilities up to versions and parameters and everything else. So yeah, if you want to have the reproducible calculations, when you want to share your study, your pipeline, your combination of utilities with somebody else, I believe that's the best way to pack it to image and share via the Docker registry.
Yeah, thank you. I think we'll have we'll talk a little bit about for those in the audience who are unfamiliar with how Docker works, image container stuff. We'll talk about a little bit later. yeah, but thank you for and I generally agree with the fact that pipeline clinical purposes require great reproducibility. Yeah, you have something to add, yeah? Or no? Okay, I think no. Yeah, then.
Sorry, I probably missed.
Okay, so yeah, if you have something to add, then please. If no, then we may turn to Roma.
Yeah, I believe I have nothing to add, but
okay.
I don't use Docker extensively outside my professional work, but it works really good when you need to have the reproducible sharing of the environments. That's a perfect solution, really perfect. I believe I love it.
Okay. Yeah. So Roma, what's your experience with again VMs and containers and like basically the use cases for both of these?
So they're similar to what was already mentioned by Gennady and Alona. So actually, our cluster requires to submit each job in a Docker container, so you cannot run anything without Docker. That's why, so I could say that we use it because we have to use it, and it helps us with reproducibility. Often I use them in pair with SnakeMake for my SnakeMake pipelines. I wanted to try Singularity because SnakeMake also have a native support for Singularity, but unfortunately I cannot run it in our cluster because from Docker container it's not allowed to run Singularity container. So that's why I don't use Singularity. Maybe in some future I'll try to it in some other computational environment. Also, we use Docker for tutoring. We have an educational class on epigenetics and data processing, and so in order to provide a computational environment for students with all tools installed, we use Docker container with RStudio and all other necessary tools installed using Conda environments, which are packed inside. And this works pretty well to make some classroom. Also, I use it for software development because our team also have several software tools related to bioinformatics. Some standard things like for sometimes for testing and etc. And as for virtual machines, I rarely use them, mostly when I need to test some of our tools using other operation systems. For example, I'm working on Mac and I'd like to test that everything works okay on Windows.
Okay, yeah, that's I think quite a common one.
Yeah.
Yeah, thank you so much for your response. Yeah, I think having said that, we may move on and discuss other things related to containers. I think there is quite a lot of agreement regarding that Docker is a nice thing for reproducibility, and that in terms of virtual machines, I think most people use it really for cases where they require different operating systems. Yeah, I also think I have to add that regarding the first part of what Roma has said regarding the usage of Docker for particular clusters which don't allow anything else but Docker, I think we have also touched upon this issue last time when we were talking about like cloud environments, cloud computing. This I think is also relevant for, we've mentioned Amazon Web Services or apps which can be used for certain tasks, including omics. And in this case, yeah, Amazon also have the so-called batch service, which can also like basically execute jobs for you. It also requires Docker, so that's quite popular for submission of some jobs to some external infrastructure. Again, Amazon Web Services here is, I think, a nice example for both genomics bioinformatics and general purpose software. Yeah. Okay. So having talked about the use cases, let's dive a little bit more into the details about the containers, because containerization, as we've seen, I think, quite well, that most of the people use VMs not for data analysis, and containers are used mostly for data analysis, and especially for reproducible data analysis, which is a cornerstone, a key topic of our seminar series. So let's talk in more detail about the containers. So there is actually quite I think a variety of different container engines, because essentially the container engine is something which provides this isolation and the ability to execute something in this container workspace. And Docker, which has been mentioned quite heavily by our experts recently, is, I think, is the most popular container engine, which is used by a lot of people and is very popular in bioinformatics. And Singularity, which has also been mentioned, which has the logo down there, basically is an alternative to Docker, which has many nice benefits, which we'll talk, I think, a little bit later. But generally, yeah, that's the second most popular alternative, at least in terms of like bioinformatics and data science. I cannot say a lot about, for example, hardcore software engineering, because I do not have much experience to that. But in terms of computational biology, in terms of bioinformatics, Docker and Singularity indeed are the most popular ones. Yeah, and if we are talking about Docker and basically how it works and how all these containerization things work, we have typically a series of like a sequence of entities. So every container, which is basically this isolated space in which a particular software runs, or a software or a pipeline runs. The container is created from something called an image. And the image is basically a template which is used to create a container. It already contains all of the necessary things. It contains the file system, with pre-installed libraries, software dependencies, etc. So basically, it's a ready template to start a container, already having everything in it. So this is something which can be shared. Again, I mentioned about sharing on the Docker like registry. We'll also talk about it a little bit later, but generally, you may share a Docker image even as a file. So Docker allows you to get this image, this template, export it to a tar file. Again, those in the audience who work on Linux systems, and probably those who work on Linux as well, may know that there is a popular archive format which is called tar. TAR, which basically is an archive folder, and Docker image can be exported as a tar file. It can be then like basically compressed to something like gzip, and you get basically something which is similar to just an archive with files, but instead of being a folder with files, truly, it is an image which you can then share with somebody, and it's someone who can import it and use it. So basically, all of this template for creating the containers and running the tools inside is within this particular image. But the image itself is built from something which is called Docker file, and Docker file essentially is a recipe for how to construct an image. So basically, what should be used, and in what manner. And I have here with me an example of such Docker file. Again, for those in the audience who have less experience with using Docker, I can very well show the example of what it looks like. Yeah. So basically, here I have my terminal, and I have well, let's look at the Vim probably. It will show nicer like syntax highlighting. So basically, a Docker file is something which looks like this. Yeah, so you basically just have a set of commands in this file which guide the Docker engine of how to assemble this particular tool. So basically, here we say that we want to take the Ubuntu 22.04, which is an operating system, Linux Ubuntu. Basically, we take this as our base image, as something from which we start. Basically, just a plain Linux operating system, and then we do like some stuff. We create or rather set the user, which will be basically the main user inside the container. From this user, all of the jobs will be executed. We set the working directory, and then basically with this keyword run, we have all stuff which is like necessary and which should be done for creation of an image. So you can see that there is quite a lot of command in here. This is not the most accurately organized Docker file. Naturally, it's a little bit messy, but the general idea, again, here you have basically just the commands which you may run in your own operating system, but you put them in a Docker file with this keyword run, and that means that when you build an image, these commands are executed, so you get the source like raw image of Linux operating system. You install on that like certain libraries, certain packages, certain tools, and that's actually what this Docker file is. So it basically just lists all of the things which are necessary to build your particular Docker image. Yeah, and then when you want to build this image, you use the command which is docker build, and this creates the image, which again you can export to a file, you can upload somewhere, or you can use it to run a container using the docker run command, which takes the image, creates a new container from this template image, and runs the tool inside this container. And of course, you can use this run command multiple times, and you can create multiple containers from a single Docker image. So naturally, again, you have the ability to start, for example, if you're running a particular tool, you may start like 20 or 40 different processes, each encapsulated, isolated into its own container. Also, a thing which I think is worth to say about Docker is that Docker has an organization which includes so-called layers. So it has like a layered file system, and generally, for example, when you have this Docker file, as I showed you, like which lists many commands. This was only a snippet, by the way, because the real Docker file which was there was like, I think, like 150 lines of instructions. But generally, if you have a Docker file which has many commands, each command will create its own layer. So basically, your image will look like this. So there was some sort of base image which is somewhere in beneath everything. Yeah, and then like so this is like the base image in here, and then when you like add something, like add some software tools, etc., you just add layers like on top of this. So that's like a pie with many like layers, many slices. And actually, when you start something, when you actually create a container, this also is manipulating with these layers. Yeah, and that's just a short note about this structure of it. Yeah, but as I've said, yeah, Docker. This is the example of Docker. Singularity, in many ways, is similar. Just is another alternative to Docker. But again, Docker has many benefits, but it has a disadvantage, which I think is quite disturbing for many people. The main disadvantage of Docker is that, or I think there are two disadvantages, which have the shared cause. And the most problematic is the fact that Docker uses the root privileges. Here I have a picture which was completely stolen from a website. I show the reference here. Again, all credits to the authors of the website. I can also show the website itself right here. Yeah, so basically that's quite I think a nice summation of the differences between Docker and Singularity, and a lot of like advantages and disadvantages are shown right here. But again, the one of the main and I think we can maybe search for for a particular word, another keyword which we need to use. Yeah, so that's about the security. Yeah, so when you use Docker, essentially all of the stuff which happens inside is executed using the root privileges. So basically, like for those who are not familiar with the Linux terminology, like root, essentially in Windows, that's like called, I think, administrator rights or administrator permissions. So basically just a super user access to everything, which allows you to delete, select from system folders, etc. So do a lot of bad stuff, which ordinary users are not supposed to do outside their local machine. And again, Docker uses these root privileges. So if somebody wants to run Docker, it should either have this root access. So basically on Linux, that means that you have to add the user to this sudo group, which has all the root permissions, or you have to add a user to a group, which is called the Docker group, which is shown right here. Yeah, so basically you have to add each user to this Docker group, but essentially everybody who can run a Docker container and knows how to run a Docker container can gain root permissions simply by running a container, connecting the file system to this container, and like running some generic thing like Ubuntu container, for example, which basically allows you to hack the system, and you get the root access to the main server. So even, for example, if I have a student and I don't want the student to have the access to like all of the system folders, etc., and I don't give root permissions to this student, but if I give him or her permissions to access Docker or add to the Docker group, then the student can start the container and basically do very bad stuff on the operating system, either like knowingly or unknowingly in some cases. So that's a bad thing, which if you have your own server, naturally you may like select the students and not give Docker rights to students who are like likely to do some bad stuff. But unfortunately, yeah, that's not a good approach. And generally, yeah, if you are sharing your resources with someone else, and you give it the access, if you give the access to Docker, you have many risks. Even again, if people are generally like modest, and you do not suspect that they may do some harm to you, at least intendedly. Singularity in this sense is better because it doesn't require these root permissions. This is a thing which, again, here I refer to Alex Predeus, or one of our experts who is not here with us today. But I asked him for the reasons why they prefer Singularity on their environment in the Sanger Institute. And he says basically the following thing, that we have a cluster, and we have many people who access this cluster. And if we give rights to use Docker to these people, they may do many bad things. So given this problem with root permissions, and the Singularity, you may give the basically this like allow to use Singularity containers without worrying about the root permission thing. So that's something which is quite a benefit of Singularity. One more thing, which is also nice about Singularity, is that it has basically a good connection with the file system. So this is illustrated with this like green arrow over here. So for Docker, you have to do very complicated stuff in some cases to give Docker access to files on your operating system. So usually I may also this nice table I think gives quite a lot of examples. So again, if you are interested, you may use the link and just study this table in details. It gives a lot of nice information. But basically, again, if you want Docker to have access to your files on your operating system, you have to do this like run -v, so adding this -v option to set the connection between some folder on your machine, on your server or your laptop, and some folder inside the container. So essentially, you have to create a connection for each folder which you want to be accessible from within the container. We have to create this like tunnel. It's called like a mount point, like a tunnel between the file system on your host and the file system within the container, which is not that terrible. And if you know how to do this, this will not be very problematic for you, but this adds like many letters to add to your command, which you use to run a tool. And otherwise, if you don't do this mounting, all the files which are created or produced by the container will basically be kept within the container file system and will not be accessible from your server. So you'll have to do some complex manipulations to get these files out of the container file system. Singularity in this sense is simpler, and it does not require all like this hard mount manipulations, I think, in many cases. So that's also, well, that's also an important thing. Yeah, I think probably that's also one of the reasons why people in this tutorial say that basically Singularity are like HPC containers, which the HPC here stands for high performance computing, which I think is, again, the lack of this like necessity to do all these mounts probably does the trick. However, again, I should say that not all Singularity containers can be run without mounting, especially if you are just converting the Docker image to Singularity image. This will basically work the same, so you'll have to add all of the folders within there. And yes, regarding what I just said, Docker images can be nicely converted to Singularity. There is, I think, one command which does it. So you basically, if you have a Docker image, you can translate it into a Singularity image with at least 1 or 2 commands. I have few, but some experience with doing this. I can say that that's not too hard. And that's also one of the benefits of Singularity, which Dr. Predels also mentioned when we spoke to him about using Singularity compared to Docker. Yeah, so that's I think some important things regarding the Docker and Singularity and the technical aspects of how Docker works. So having said that, I think we may look at the results of our questionnaire again. So we had a question regarding the usage of different container engines. And I think here we have the majority of the audience who have used Docker over Singularity, which I think is quite expected, given the fact that Docker is more popular, I think, and more tools are natively created for Docker. Singularity, again, can convert Docker images, but it doesn't have, I believe, its own repository of images. But yeah, quite some people have experience with using Singularity, though much fewer than Docker. And regarding the usage of containers, I think that, yeah, we have an overwhelming majority of people, at least 8 out of 10, who say that they consider the running and usage of containers too complicated, which I think in much of this is related to this stuff, the mounting the folders. So basically, when you should connect all of the folders which you want to use within the container, you connect them to your like folders on the host system. Then when you run the command, you have to remember that like the name of the folder is different. There's a lot of troubles related to that. And that's, I think, why people say that containers are in many ways overcomplicated. Yeah, and that's also, as I've already mentioned, one of the reasons why people tend to prefer Singularity with some people. Okay, so having said that, I think I can we can ask the people in the audience, or at least in the experts, regarding this Docker versus Singularity preference. I think that, again, I've mentioned that Dr. Prideaux says that they in the Sanger Institute strictly use Singularity. I think that you already mentioned that most of the experiences with Docker, but if again, Roma, if you could comment on the choice Docker versus Singularity, whether you have looked into Singularity. I understand, for example, Roma, you have the limitations of the cluster, but generally, maybe you have something to add.
What I can say that I believe it was a choice from our infrastructure team, and it was not about the limitation of usage Docker or Singularity itself. In fact, I have no experience even in work with Singularity, but the main reason was the orchestration system like Kubernetes, something similar. So they usually don't think about the single containers and manual running. They use some container orchestration, and I don't know in fact why they prefer that. This was just probably the popular solution, or probably there was some infrastructure needs.
Okay, again, you mentioned Kubernetes. I think that if you could say a few words about it, because I've heard this like the name of this quite several times, but I have never used it, and I still I think have quite bad understanding of what that does. So if you could say a few words about Kubernetes and what is used for it, would be nice.
I can say only a few words because I had no experience with Kubernetes myself, but as far as I know, that's probably can be wrong. So please don't trust my words, and it's better for you to recheck it. But as far as I know, Kubernetes is kind of the orchestration engine which can automatically start, convert, and run containers. So, for example, let's imagine that you have the Illumina high-sec system, which sends you about 6 terabytes of data, and you need to analyze all these samples. And you need to create many running containers for many running processes. And I believe contains that even you can have a master script, which, for example, pulls to some image container for one utility, from calculation, for other container, run the data inside the container. So it's Kubernetes is kind of the big data processing. When you have thousands of containers, and you need to control them. So I believe not our case, but it's important when you go to production.
Yeah, thank you. Yeah, that's I believe not something which may be used by or which is used by people who do routine data analysis, but truly, yeah, the word pops up when you talk to people who use some software engineering, and again, given the fact that we in our practice we use Docker and we develop even some pipelines with Docker. Yeah, for me it was also always interesting to study it in more detail. Unfortunately, I wasn't able to so far, but yeah, that's probably not pertinent to routine data analysis, but still important to mention. Yeah, Roma, so if you what's your do you have something to add on this, like Docker versus Singularity choice, apart from basically just the infrastructure limits?
Unfortunately, I'm not experienced with Singularity, so I can't add anything useful.
Okay, yeah, that's fair. I think quite a lot of people with us here have never used it, so that's probably. I suspect that actually in this questionnaire which we have over here, the two people who have used Singularity is like me and Alona, probably. Yeah, and both of us have already mentioned something about the benefits, etc. It's also quite, I think, quite important and nice to mention that basically when we have in this table of like comparing stuff, we have like these people who created this table of comparison. They basically say that about who uses things. And for Docker, they say that basically that's development and DevOps, which is like the deployment of applications. And the Singularity, they say basically like this science users. And I think they have also like some other stuff like Schiffer, which I think I've also never heard of, but they also mentioned that as something which is used for users of scientific applications. Yeah, so these alternatives seem to be specific or at least more present in the scientific domain. And yeah, Docker is very heavily used in software development, software engineering as well. Regarding what Gena said about the Kubernetes, I've never used, as I've mentioned, I've never used myself. But what I have used, I should say, is Docker Compose, which is a second, I think, important thing about Docker. Yeah, that when you have Docker images or you have like Docker applications, especially the ones which are like running always, which is like not one tool which you just like run it and forget about it. But if you need some application which needs to be accessible, like a web interface or something else, which requires like many configuration, for example, yeah, and when you have multiple containers, you may also use Docker Compose, which is an additional solution which basically can automatically build and restart the containers. So it has its own configure file. It usually looks like this. So for example, if I have an image called my app, I can say that I need a container, which will be called like basically my server, and which will be using this my app image. And here I can write down things which I want this container to include. So I want this like mount of the folder, which is this Docker -v option. Basically here I say just like take this folder with sequences and mount it as some path which has this like reads keyword in it. So basically just here I write down the mount points which are necessary. Here like the ports, which is basically a network configuration. So in this like Docker Compose file, you may include many of these instructions. And if you use something repeatedly, not once, or if you have an application which persistently runs in there, Docker Compose is a nice thing to do. And again, it may be easier to set all of the things up and not basically just not think about all of these like complicated properties which you have to add to command line each time you run something. And again, but this is just a single use case of Compose. Again, I'm not the best example here because I'm not a software engineer myself. I think genuine software engineers have much more to say about it. Yeah, and one of the use cases for Compose is also like this orchestration and management of multiple containers, which in some cases is important, probably not for people who do routine data analysis day by day, but at least may simplify working with Docker containers, especially with complicated setup. Yeah, so that's what I have to say also about Compose. Returning back to the general issues and then basically the general Docker and Singularity workflow. We've mentioned already that you may share the images, which are these templates used to run the software tool. But it's also important to mention that, yes, you can not only share it as a file, but you can also share it in the registry. And that's, I think, the final topic, which is important to be considered, yeah, in the when talking about containers, because there are many like hubs and platforms on which you can share your image and which on which software developers share their images. So for Docker, there is a Docker Hub, and Docker Hub is basically a very large cloud of images which may be used in you know, like on your own system. So you can just take the image which was already built by somebody, just pull it. There is the command which is called Docker pull, which basically you just write Docker pull and the name of the image in the Docker Hub, its address, and then you basically just do the pull. And the image, which was built by someone else, arrives onto your computer. And with again, Docker Hub is a very large thing, and almost any tool which is heavily used in bioinformatics has an image in Docker Hub, at least most of them. And the ones which are heavily used, so for example, GADK variant calling thing is, I think, the recommended thing is to use it via Docker. The deep variant caller also in Docker, and many other tools. So like almost all of them have something on Docker Hub, which basically means that you just have to pull the image and you have it, and then you just basically can run the container. So for most of the tools in bioinformatics, the typical sequence of steps which you need to do to use the tool is to do Docker pull name of the image, and then Docker run name of the image, and then the command which you use to run. The only, again, complication with Docker is that you have to set all of this like mount points of, you have to provide Docker with the instructions on how to connect the folders, which is a little bit tough, especially for newcomers, for people who are not that experienced in for example, Linux terminal. But generally, like 2 steps is a complete pipeline for using a containerized app. And for bioinformatics tools, many things are on Docker Hub, and many things. There is also a specialized container repository, which I think talked quite a lot in this seminar series about like Bioconductor is a repository of R packages for bioinformatics. The Bioconda and related things for tools which are implemented in Conda, and Python packages which are related to bioinformatics. So yeah, and biocontainers is basically yet another repository of tools for bioinformatic data analysis, which I think also includes, probably if something is not in Docker Hub, should be there in biocontainers. I shall say that in my practice, all of the stuff and all of the tools which I use personally using Docker, I have never turned to biocontainers. Probably everything which I need basically was there in Docker Hub. So I've never used biocontainers in my work. Yeah, so maybe again, Ram, again, if you've used something from biocontainers, yeah, please feel free to comment on that. Yeah, so have you or have not? Roma, have you used something from biocontainers, or Docker Hub was enough for you?
I haven't used, so
okay.
Docker Hub was enough for me, but I made my Docker containers by my own.
Mm-hmm. Yeah, of course you can make your own images. Yeah, Docker Hub is okay. So Docker Hub was enough for you. Yeah. So Gena, have you had like any interactions with biocontainers? Okay, I think that Gena may also have some connection problems. Yeah, but I think that that quite sums it up. That if like we have not seen anything which is not there on Docker Hub, it probably means that for most cases it's quite enough.
I'd like to add that it could be many other repositories for Docker container, for Docker images. For example, our clouds in WashU, it has own internal repository, so they suggests using their repository because it will be fetched faster compared to Docker Hub. And also it's like private with some data and other security policies.
Yeah, private repositories. Yeah, I think I also have seen once how people use this, but not in my personal practice. Yeah, but thank you for the comment. Yeah, that's an important issue. Yeah, I think I have also one thing which I forgot to mention previously regarding the usage of Docker and all of these like mounting the folders and using like different kind of things to mount stuff. I think many of these issues, when you have to do like complex manipulations with this like Docker -v, etc. I think those examples somewhere down there can be solved quite nicely with SnakeMake and Nextflow. So basically, when you have pipelines which are built using pipelining languages, in many cases, yeah, you may, for example, for SnakeMake, you can set to run something in a Conda environment, and I think you can set to run something in Docker. And for sure, you can do this in Nextflow. I have not, strangely, despite the fact that I have used SnakeMake more often, with Docker, I have only interacted with Nextflow in terms of running particular tools in a pipeline within Docker containers. So Nextflow does it very nicely because you basically can just write a name of the image, and if you provide all of the inputs and outputs for the tool, and you set the Docker container, basically everything is handled for you. So you don't have to worry about this complex like folders, etc. You don't have to run Docker yourself. You just in this rule or a process in Nextflow, which when you describe like a step of analysis, you basically just can include the name of the image to be used for this particular step. And when you execute the pipeline, Nextflow will automatically take for this particular step, it will take the Docker image, create a new container, and handle all of this stuff regarding mounting the folders, getting the outputs, everything will be handled back for you. So you just have to write the name of the image of Docker, and things will be executed in Docker, which is also quite a nice thing if you want not to worry about how to do all of these complex like folder manipulations. Yeah, and I think SnakeMake has something similar in terms of executing in Docker. And sure, of course, you can include both SnakeMakes and Nextflow in Docker. So for SnakeMake, I had, I think, once an experience of like putting a complete SnakeMake workflow into a Docker container, which also works quite nicely. Yeah, so that's what I have to say about the topic. And thanks to everyone for participating in today's discussion. If there are any questions regarding the usage of these containerized things, then please feel free to ask. Okay, seems that there are no questions, and that means that we can conclude the seminar series. Yeah, thanks to all of you for participation. A separate thank you to experts who have participated in this session, who have commented on things and shared your opinions. That's extremely valuable. And I hope that this series was of interest to the audience. We will, regarding the future steps, we will compile a summary of these seminars as a text, including like graphs from our forums, questionnaires, and details of what we talked about, links to software and to libraries and to solutions which we've talked about, links to materials on the web. So we'll share it in a form of basically a page on our website. Yeah, and the recording of today's lecture, of course, will also be made available on our website, on the website of the seminars. Yeah, so again, thanks to everyone for the attention, and thanks for everyone who has helped to make these seminars happen.